Good morning, students. Welcome to your mathematics class. Today we are going to start another important topic in your 2D, that is circles. Whenever the word circle comes into the mind, it is very known to us that how this plane figure looks like and how this plane figure forms. With the definition, if we are going to explain what is a circle, then we very quickly say it is nothing but the locus. What did I say? Yes, locus. What is locus? Path traced. It is the locus of a point which always moves in such a way such that it maintains a fixed distance from a fixed point. The fixed distance is known as radius and the fixed point is known as center. So here I have already written, this is a circle and a path traced, a circular path with radius say R, with center say O. And I have taken the center coordinates as alpha beta. Okay, children. Now, the standard equation of a circle, if we wish to write down, then it is given by x minus alpha whole square plus y minus beta whole square is equals to radius square. See, this is alpha beta. And here we are placing alpha and beta. So, this is the standard equation of the circle. When the center is at origin, that is like this. The center is at origin. Then this alpha and beta both are going to be 0. So in this case, x minus 0 whole square plus y minus 0 whole square, and the immediate equation we are getting is x square plus y square is equals to radius square. Okay. Using this standard equation, we can find out the equation of the circle in different positions of the circle in your two-dimensional plane. Say for example, I am taking when the circle touches both the axes. That means the figure will look like this. Here it's the x-axis and it's the y-axis. It can be here also, like this also. I have taken certain example like this also. So the circle touches both the axes. If it is in the first quadrant, then it is A and A. So the center coordinate alpha beta is A comma A. And the equation of the circle will be x minus A whole square, y minus A whole square, and the radius is also whole square. So if we are going to expand this one, then we are going to get x square, y square, minus 2xa minus 2ya, and the constant part from here a square, that a square will cut down with this. We are left out with only one a square. That is this. So, this is one example. Another examples, say if the figures looks like this. See these figures. What can we see? That the center coordinate lies in the y-axis and the center coordinates here lies in the x-axis. So if the center coordinate lies at y-axis, then it will be 0 comma a, and when it is lying in the x-axis, it will be a comma 0. So accordingly, the radius is going to become a only. So we are going to substitute it. Since y minus 0, that is y square only, it is equals to again a square, that is the radius square. And hence what? We are getting the formula by expansion, that is x square plus y square minus 2xa, because that a square part will be cancelling with the a square part. Okay students, so like this you can solve this, and the various problems we will be discussing later. We can see how we can make use of this standard equation. With standard equation, we are mostly using one more form of equation of a circle, that is your general equation. What did I say? General form. Okay, the general equation of a circle. And the general equation you will find it is written as this. See what I am writing? It is x square plus y square plus 2gx plus 2fy plus c is equals to 0. Now let me see why the general equation is different from this. Actually, this is the same thing only. How it is same? Let us see. If you are going to expand this one, what are you going to get? Check here. You are going to get expansion of the whole square formula, that is x square plus alpha square minus 2 alpha x, y square plus beta square minus 2 beta y is equals to, so this is r square, the radius which is always there. Okay. Now do one thing. We are going to take this one. See, this is the expansion of the formula where you have involved all the 6 terms. We are going to bring this r square in this LHS part. So after bringing it, how can we match it with the general equation which is taken in your course book or which is very commonly used? Let us see that. Okay. Let us substitute some g as minus alpha, some f as minus beta. Check. Then in this case, what we are getting? X square plus y square plus 2gx, isn't it? If minus alpha is g, then 2fy, see? Here, in the place of alpha, we can write here g square, then f square, and see students, is it okay? Now you do one thing, look at this part. This is some constant, no? It is clear to everyone that when we are going to calculate this one, this is going to provide me some constant. So let us name it some constant C, and I am going to write here some constant C. Check here. Let the C be g square plus f square minus r square. Okay. So what is r square? And thereby what is r? That is the radius. What is r? Yes. So written here? All of you can see this R. It is G square plus F square minus C. And here I am going to substitute that C. So have you noticed that how I have transformed the standard form to the general form? Fine. And we are going to remember few things about the general equation. I'm going to rub it, and what the points we have to collect from this discussion. The first thing is the first formula we have written. Secondly, the general form. In this general form, we have to remember the center coordinates. What did I say? The center thereby is minus d minus alpha, as we have substituted. And the radius is root over of. Obviously, when the root is there, we are not going to get the negative answer. We will be always taking the positive answer. So this we have to remember for general equation. Suppose you are provided a problem. We are asked to find out the radius and the center coordinate of any equation written in the general form. How can we write that? Let's see that. Suppose you have a problem and it is, say, 2x square plus 2y square, then it is minus 3x plus 5y, and it is equals to, say, 7. And we are asked here to find out the radius and center coordinates. First of all, make these coefficients away from x square and y square. So for that, if you are going to remove this 2 from here, so you are going to get this divided throughout by 2. Now comparing this with the first equation. Compare with the first equation. Say if you are bringing this also, it will look completely same. Then in that case, what is G? What is F? This is my immediate question, no? What is G? What is F? Here you can see that 2G is equals to minus 3 by 2. So what is G in that case? Minus 3 by 4. And similarly 2F, it is 5 by 2. That implies, what is F? It is 5 by 4. You can do directly also. I am explaining because this is a beginning of the class. Later on you will be able to do very quickly. Just have to divide it by another 2. Correct. And if somebody is asking me the center we know minus D minus F. So in that case, that minus sign will be over. It will be 3 by 4. And here another minus sign will be put. That is minus 5 by 4. Okay, students? But that's not all. We have radius. Correct. For radius, substitute here G. That is 3 by 4 whole square. Here 5 by 4 whole square minus C. Now what is C here? Minus 7 by 2. So this is this. Now we are going to calculate the value and you will be getting your answer. You just calculate and the positive square root is your answer. Okay. So this is for your general form and the standard form of a circle. We will be doing the problems in our classes using these forms, the various category of problems. But what we are doing here, only discussing about the basic formulas and theory of the circle. If some way you are provided the 2 points on the circle, say A and B, and you have these points as the extremities of a diameter. Okay, so in that case we are going to get the diameter formula by using the previous general equation. By making these points to be satisfied in that equation, we are going to get the diameter form of a circle that is given by x minus x1 into x minus x2. See, notice here, x minus x1 into x minus x2 plus y minus y1 and y minus y2 is equals to 0. So this is known as diameter form of a circle. And we have to remember that whenever we are provided with the diameters, the extremities, okay, the coordinates on the circumference of the circle, and which happens to be the extremities of the diameter, we can use this formula. Okay, students. Then in this entire session, we will be studying more about the different forms of the circle, the 2 intersection of the circles, okay, and how to find out these equations. Okay, students. So this is the theory part. Just go through them and get prepared for your upcoming class, okay, where we will be discussing these problems, the problems based on this particular chapter, okay, and these formulas will be used and the applications will be understood better. Okay, so that's all for today. Have a good day.